Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our closure homework in preparation for the chapter 1 test. No, not chapter 1, for the chapter 2 test number 1. We want to be experts at going back and forth between fractions and decimals. So remember, when you're starting with a fraction, to convert it to a decimal, you do the division. So 13 divided by 9 ends up giving you a repeating decimal of 1.4 repeated. 7 divided by 8 ends up giving you a fraction that's less than 1, so the decimal number is also going to be less than 1. And I often have students that struggle trying to remember whether or not this number 7 is supposed to go inside the box, or if the 8 is supposed to be the number that goes inside the box. So the way to know is to understand that a giant 1 would say 8 over 8. But this is less than 8 over 8. It's 7 over 8, which means it's got to be a number that's less than 1. So when you do the division, how many times does 8 go into 7? 0 times. How many times does 7 go into 8? 1 time. This one is wrong. So the number that's on the top is what you're dividing into 8 equal parts. So you're dividing by 8, so the 8 goes on the outside and the 7 goes on the inside. This is the trick I used to use when I was younger, and I could never remember which one was supposed to go in the box. Just do a little mental math to determine whether this should be more than 1 or less than 1, and then choose the appropriate number to go inside so that you get a 0 in the ones place. Here we are going in the opposite direction, where we have to identify what place is the last digit in. It's in the thousands place. So you write it as a fraction, 204 over 1,000. But then you have to remember all fractions must be simplified. So it turns out 204 and 1,000 have 4 in common. So divide the top and the bottom by 4 to get this fraction in simplest form. For D, there's no simplification required. 47 hundredths is already in simplest form. All right, suppose Cecil, the tightrope walker, can only travel lengths of 5, 6, and 8 feet. All right, so he could travel forward or backwards, which means you can add or subtract, right, or add a negative, any of those distances. Show 2 number expressions that represent a way that Cecil could walk the tightrope for these given lengths here. So there are actually tons of different answers that you could choose. Excuse me, you just got to know that using the given lengths 5, 6, and 8, you can take as many steps as you want as long as the final result is equal to the number in question. Okay, so you may have some different varieties that worked. These are just some that I came up with. All right, Cecil started at point A and moved across the expression according to this. So he went 8 feet, then -5, then 7, then 6, then -7, then 5, then -8. What one additional step does he need to do in order to return to his starting point? Now remember, if he returns to his starting point, that means that the total sum of all of these numbers has to equal 0. Because 0 is where he starts, and wherever he ends is a bigger number, right? So if we take and we add, let's find all the 0 pairs here. He took a -5 and a +5. He had a 7 and a -7. He has an 8 and a -8, which means he needs a pair for the 6, which should be, ooh, I didn't write that in there properly. Hold on. It's supposed to be oh, I get what it is. The total sum of all of those numbers was 6. So he needs a -6 to balance that out to get back to 0. Rewrite each one of these as a product, or each one of these products as an addition statement. So 5 times 3 means you're literally adding 3 together 5 times for an answer of 15. 3 times -2 means you're literally adding together -2 3 times to get -6. And here's, we haven't done this in a while. George is playing a game, but the spinner is incomplete. Help him figure out what fraction is missing. So in order to do this, we need to remember that the total sum of all of these wedges adds together to make the whole, which is 1. So it means that 2/5 plus 1/3 plus this missing number has to equal 1. So what we want to do is we want to find out the sum of these two numbers. So you'll have to find a common denominator. So 15 ended up being our common denominator. And when you add these guys together, you get 11. So 11 plus something gives us 15. Why is this a 15 here? Because this is equal to 1. So we need to rewrite that as a giant 1 with 15 in the numerator and denominator, which means this number must have been a 4. So this missing wedge must be 4/15. Now, if you want to prove it, add 2/5 plus 1/3 plus 4/15. And if you don't get 1 for an answer, then this would be wrong. But I guarantee you, you're going to get 1 for an answer. And I believe that's where we end today. So next, let's move over to the study guide and see how you did on the study guide. Take care. Bye.
Hey, feeling good, like I should. When in Durga,